Randomness, a fascinating concept that often eludes our human intuition. Have you ever wondered how we approach a seemingly simple task like selecting a number from a grid? Let's dive into the world of randomness and explore the intriguing differences between human bias and computer-generated randomness. Imagine you're faced with a grid of 25 numbers, ranging from 1 to 25. How would you go about selecting just one number? Assume a person starts by selecting number 7 on the grid. The human brain, remarkable as it is, can still fall prey to biases. Based on the previous choice of 7, our brain might subconsciously select numbers that are far apart from each other, believing it brings a sense of balance and randomness to their choices. So in this case, a person would try to select a number which is far from 7 as possible. Our inherent tendency to perceive patterns and seek order can inadvertently influence our choices, introducing a bias that clouds true randomness. Now, let's contrast this with the power of computer-generated randomness. Using sophisticated algorithms, computers can simulate randomness, free from any biases or preconceived notions. Watch as the computer effortlessly selects 5 numbers from the grid, each chosen randomly. These selections are not influenced by previous choices or any predetermined patterns. We will repeat this process multiple times and there is no logic or pattern to how the numbers are being selected. While our human brains tend to be guided by unconscious biases and patterns, computers excel in producing unbiased, random results. This distinction is crucial in various fields, from research and statistics to gaming and cryptography. So, the next time you encounter the challenge of embracing true randomness, remember the contrast between human bias and the power of computer-generated randomness. It's a reminder that sometimes, the unpredictable and unbiased nature of randomness can lead us to new insights and opportunities. In everyday life, randomness can be observed in various scenarios. Imagine you're standing at a busy bus stop, waiting for your ride to arrive. As you look around, you notice a stream of people joining you, some in groups, some alone. Curious, you strike up a conversation with a fellow passenger, eager to understand how one can predict the number of people arriving at a bus stop. You ask them, how would you normally go about predicting how many people will be here? While historical data and general trends can provide some insights, the randomness of people's arrival at a bus stop adds a layer of unpredictability. It means that even during periods that may typically have higher or lower demand, the specific order and timing of individual arrivals remain uncertain. Transportation planners and operators take this randomness into account to ensure they can efficiently manage passenger flow, optimize service schedules, and respond to the ever-changing dynamics of people's travel choices. As hurricane season approaches, the topic of predicting the path of these powerful storms becomes increasingly important. Picture yourself in a room filled with concerned individuals, including a seasoned emergency management professional. With hurricane preparedness on everyone's mind, you turn to this expert and ask, how would you typically predict where to begin evacuation efforts? Hurricanes are complex weather systems influenced by various factors such as atmospheric conditions, ocean temperatures, and interaction with land masses. Despite the best efforts of meteorologists and advanced technology, the precise trajectory of a hurricane remains uncertain. Randomness manifests in the form of unpredictable variations and fluctuations that can impact the storm's path. This recognition of randomness is crucial for emergency management professionals who must make critical decisions regarding evacuation efforts. They must consider the various possible paths and associated risks to determine which areas are most likely to be affected. It's a delicate balance between ensuring public safety and optimizing resources while understanding the inherent unpredictability of these massive storms. In the world of medical research, clinical trials play a vital role in determining the effectiveness and safety of new drugs or treatments. Imagine yourself in a conversation with a curious listener, discussing the evaluation of drug effects on different individuals. You turn to them and ask, how would you typically assess the effect of a drug on different people? Randomness plays a crucial role in clinical trials as it helps ensure unbiased participant selection and treatment assignment. By randomly assigning participants to different treatment groups, researchers can minimize potential biases and confounding factors that may influence the results. This randomization process allows for a more accurate assessment of the drug's effects and increases the validity of the trial. Without considering randomness, clinical trials would be susceptible to various biases. Non-random participant selection could lead to unequal distribution of baseline characteristics, rendering it difficult to attribute observed differences solely to the treatment. This could compromise the reliability and generalizability of the results. Randomness lives with us and affects everything we do in our daily lives.